Starting up the stream. Advent of Code 2021, days 13 and 14. Let me do an audio check. Test. Advent of Code 2021. Okay, good. All right. I actually have the transcoder today too. All right. Let me just get set up to do day 13 and 14. Day 13, and let me delete all the code from here. All the way down to, oh, there's a lot of code I did. Day 12, wasn't there? All the way down to here. And this becomes a to-do. And that becomes a to-do, and this goes away. And we probably only have maybe one example. Whoops. $13 there. While I'm at it, let me copy 13 to 14. Put a 14 there. Okay, so lib. Mod day 13, mod day 14. Let's copy 11 twice. 12. Oh, what did I do 12? It should have been 13. Because 11 plus 1 is 12, but 12 I didn't want to copy because it was too complicated. All right, I need empty files for 13.txt and 14.txt. All right, and then probably it should just set this up now. 13 and 14. 3, 3, 4, 4. Okay, and then let's go to terminal, do a cargo run 13.1, 13.2, 14.1, 14.2. Okay, cool. Let's get the browser window set up, shall we? Adventofcode.com. Here we are. I got 22 minutes before day 14 unlocks, so if I could do 13 really quickly, I'll get it on time, but probably not. All right, so what is Advent of Code? It's an Advent calendar of programming challenges, 2 per day, December 1st through 25th. They're Christmas themed. There's usually a pretty corny theme that goes along with it, but it's all in good fun. A lot of the puzzle example puzzles are contrived to fit with the theme. Generally, you just have to write a program that takes some string input and gives you a number output, and you enter that into the site, and the faster you can do it, the higher the rank you get. If you're going for a speed contest, you have to beat the top 100, and they're usually very fast. The first year it wasn't as popular and they weren't as fast, but now it's like if you can't solve it within 5 minutes, you don't get any points. But we're just doing this for the learning, the enjoyment of the process. Hey there, Smack in the Box. How are you doing? So I just gave my intro spiel about Advent of Code. I need to catch up. I didn't do day 13 on time. Day 14 is going to unlock soon. So the theme this year is that we're on the ocean and oops, dropped the keys to Santa's sleigh into the ocean. So we had to hop into our submarine, and then we're going through all these adventures every day, chasing down where those sleigh keys went. So we have to save Christmas, basically. Every year we got to save Christmas. It's up to us. So let's see. Day 12 was about we're inside a subterranean subsystem. No, we're in some subterranean caverns, and our submarines, like navigating systems, are like going through the caves, and we had to do some path finding in that. So let's see what we're going to get in store for day 13. Transparent origami. You reach another volcanically active part of the cave. We're in our submarine still, I hope. It would be nice if you could do some kind of thermal imaging so you could tell ahead of time which caves are too hot to safely enter. Fortunately, the submarine seems to be equipped with a thermal camera. I need to not slouch. Hold on. Let me fix my setup here. When you activate it, you're greeted with congratulations on your purchase. To activate this infrared thermal imaging camera system, please enter the code found on page 1 of the manual. Apparently, the elves have never used this feature. To your surprise, you manage to find the manual. As you go to open it, page 1 falls out. It's a large sheet of transparent paper. The transparent paper is marked with random dots and includes instructions on how to fold it up, your puzzle input. For example, so when they say for example, we want to take that text, literally copy it into our test for part 1, paste it there, and line it up. Okay, and then they're going to give us like what answer that should go with, like down here. I'll just cheat and go down here. 17. They usually put a box around it so we can tell. I think it's one of the things that the speed coders use, like when they parse the puzzle input, they're looking for a box with a bold number in it near the end to say what the answer should be. Either that or there's some API to get this information out anyway. Hey there, A Squared. How are you doing? Yeah, the paper folding. Yeah. The first section is a list of dots on the transparent paper. 0, 0 represents the top left. The first value x increases to the right, y increases downwards. So the coordinate 3, 0 is to the right of 0, 0, and the coordinate 0, 7 is below 0, 0. The coordinates in this example form the following pattern, where hashtag is a dot on the paper and dot is an empty, unmarked position. Yes, so they mark them, and they give instructions to fold along. So x7 would be the column 7, fold it there, right? Each instruction indicates a line on the transparent paper and wants you to fold the paper up for horizontal, y equals, or left for vertical lines. In this example, the first fold is to fold along y equals 7. I thought it said x. Oh, it does say y. All right. So fold up at y equals 7, which designates the line formed by all the positions where y is 7 marked with a dash. So we folded by, okay, we just mapped them on top. So it just drew the line first because it didn't change any other line. And now there's a fold. Because this is a horizontal line, we fold up. Okay, so we just added together. Some of the dots might end up overlapping at the fold's complete, but dots will never appear exactly on a fold line. Is that right? Yeah, there wasn't any dots on the fold line. Okay. The result of doing this fold looks like that. Now only 17 dots are visible. Notice, for example, the 2 dots in the bottom left corner before and after these dots appear in the top left. Got it. Because the paper is transparent, the dot just below them in the result remains visible. So you can, yeah, so it's, I get it. They can end up overlapping in the case they merge together and form a single dot. Second fold does that. So this is symmetrical folds, right? Begs the question of what an asymmetric fold would do. Vertical line, it folds, you're right, and it folds into a square. This instruction is made a square. Transparent paper is pretty big, so for now, focus on just completing the first fold. After the first fold, 17 dots are visible. Dots end up overlapping after the fold is complete. How many dots are visible after completing just the first fold instruction? Let's get our puzzle input, and I want to see like if indeed there are some asymmetric things in there. 17 or 13 dot text. Gotta keep an eye on the time because I kind of want to start 14 on time. So it's pretty big. These, actually, I think these are folding in the middle, aren't they? Yeah, these are folding right in the middle. So they're always symmetrical. I guess we could do a check. If this number is 1/2 of the width or height plus 1, right? Because it's going to be odd. I guess that's another thing we should check. How's it going? Hey there, Devil Squirrel. How are you doing? You can't do this in real life, let alone with coding. Yeah, that's what I was thinking. Just doing a simple union, and especially because I only have 15 minutes left. Asymmetric fold will work with this as long as the bottom right is smaller. Yeah, but they didn't go through an example of that. I guess I could support that, but maybe I just my code might doing it anyway. Let's see how things unfold. See what I did there? So one thing I got to do is split the holes from the instructions. I guess we'll do that by looking for the first blank line, since that's the easiest. So let lines, let's just do this like this. Lines, map, line. Let me turn off the inlay hints for a little bit because it's getting annoying. Trim, collect. Actually, I'm not even going to bother collecting it. We'll just keep it as an iterator. So, yeah, iterator. Okay, so then mark this to do. Okay, so let's just say while let some line equal lines. I think I can break out early if it's empty, right? If line dot is empty. How come it's not helping me? There we go. Break. I can do that, right? And then then we'll just consume the rest of it, right? This should be next. Well, except for I have a break. Can I turn that into a 4 with a break? I don't know if I can, because I want to have another one after here. For line in lines. Okay. I guess I can do that. The break will stop early. And then this will let me get the... So let me just test this out. Instruction. Let's just test this out. Then I should only see it print the instructions. Yeah. Okay, so I guess you can. I wasn't sure if you could break out of a for loop. I hardly ever do that. When I see this, usually I think it's going to do all the lines, and don't look for those. Anyway. Which one do I want to handle first? The instructions? Because I'm just doing the parsing. Let me think about this. I don't actually need for an efficient solution. I'd want to make a vector. I guess I can just look at my input and see what the extremes are. This one. So it's probably double that. So what is that? No more than 1300 or so. I don't know. 12 minutes left. Calculator, help me out. 655 times 2 plus 1. 1311. Does that mean that there's a 1310 here? Yes, and there's no 1311. Okay, so knowing that, I can place a bound on the memory I allocate. But do I actually need to allocate memory? Or do I just remember them as like a list of holes that I want to be able to quickly fill in? Do they even need to be like in any kind of like data structure? Because what we're doing is the folding is just going through, and if something is on the wrong side of the coordinate, we just flip it. And then, so we need to be able to iterate through it relatively quickly, and then given one, when we transform it, we need to find if there's another hole already there or not quickly. I'll just do with a non-optimal solution, which is a hash map. So this would be let mute holes equal hash set, right? Let's import hash set. 10 minutes left, or 9.5. And then otherwise it's holes.insert line.split once at the comma, and then unwrap, and then map x and y to x parse, I don't know, usize, unwrap, and then do the same thing for the y. Oh, let's move the unwrap to the end. And that's not actually not the end, but inside the insert. Why didn't it like that? Oh, that already is a tuple? That split once gave me an option, right? And then maps if it's something. Oh, I had not enough parentheses. There we go. It's always a matter of parentheses when it comes down to it. Hey there, Phil Powers. How you doing? My Ultima project I gave up on because I wasn't having fun anymore. And that was one of the prime directives of doing gaming on stream. I felt like I was narrating my gameplay, and there wasn't anyone watching who really cared about that. So I'm like, why am I doing this? I think the fold can be slightly off from the halfway point, so it's not exactly on it. Okay, so I guess we'll support that if it's slightly off it, we can do that. Curious about the newer games? Yeah. I think also because I was doing Ultima 6 at the time, and the games actually start to get pretty difficult in terms of figuring out mysteries, like murder mystery. Who killed? I was in Skara Brae in Ultima 6. I was trying to figure out who killed Quentin, and I couldn't figure out. And later I looked it up, and it's like, well, you're not really. There's no way you can solve it in game. You can figure out who did it, but there's nothing you can do about it. I'm like, well, that sucks. But that experience kind of left it sour for me, so I kind of stopped. Okay, so we should have the holes parsed and into hash set. So then, how do we parse this? We just want to strip off the prefix and then split on the equal, right? So lines dot split map line dot. Ultimately, we have a direction and a what do we call that? Coordinate. Line dot strip prefix. The prefix is fold along space, and then unwrap that gives us what exactly? Tuple, right? No, it's a string. So let's map, because I'm trying to do this functionally, the line with line dot split once on an equal. And not map, it's going to be and then. And I don't like writing code horizontally, so let's put a line break in there for now. So strip the prefix and then split once, and we want to map then the the direction and the coordinate to, I guess, we're going to have a tuple of some kind. For the first one, I'm going to match the direction. It's either x, we'll say dir horizontal. I'll make up an enum on the fly here. And y, it's the other way around, vertical. Horizontal. And this is unreachable. Okay, and the other member is the coordinate parsed as a usize. Unwrap. And I need to make this enum now. So, enum, direction. Horizontal, vertical. Okay, so we have a direction and a coordinate. So then I just want to map, right? Or match the direction. So it's one of two things. I guess we'll just make them into subfunctions. So fold horizontally the holes at the coordinate, and this one will be fold vertically. And we do that for all the lines, and at the end, they would just want us to count how many holes are left, right? So it would be holes dot count, well, holes dot length dot toString. Okay, so I just need these two functions. It's that simple. Fold horizontally the holes, which are mutable hash sets of coordinates, so usize, and we have a coordinate which is a usize. Well, which we know is going to be, if we're holding horizontally, it's a y coordinate, right? And that doesn't give us anything, so let's just mark this. Make sure the syntax is right? So define the functions. I got 2 minutes left. I'm not going to do this on time, so I'd rather just jump to day 14 when I'm about to run out of time, and we'll come back to this one. But let me make sure I have no syntax errors. Good. So this is an X. And I think we just iterate through all the holes and we're going to filter out and find where all the ones are on the right or the below, and then map them and then put them back into the original holes, right? And so these are going to be pretty similar, only one's going to, actually they're just going to have different conditions, right? So what if I just have one fold function and then the condition on like how to, there's going to be two things, how to know it's on one side or the other of the fold, and then how to transform it. So those could be like two different functions. Anyway, I'm out of time. So we'll get back to day 13, but I kind of just wanted to start day 14 on time. So I have 1 minute left to get hydrated, to get set. So with 1 minute left, hold on, let me take a drink. Let me just explain again what Advent of Code is. Yes, it's that simple. Nathaniel Bumpa, how are you doing? Advent of Code is an advent calendar of programming puzzles. They're corny Christmas themed. December 1st to 25th, you get 2 puzzles. They unlock at midnight Eastern time. The theme this year is we're on the ocean. We drop the keys to Santa's sleigh into the ocean, and we got to go find them to save Christmas. So we're in our submarine. We're going down into the ocean depths, and anything from giant squids to hydrothermal vents that we're navigating through. It's all just contrived to make up a small algorithm or coding puzzle. So in just about over 10 seconds, we'll know what today has in store for us. All right, big breath. Here we go. Day 14. And someone's already solved it. Just kidding. Extended polymerization. The incredible pressures at this depth are starting to put a strain on your submarine. The submarine has polymerization equipment that would produce suitable materials to reinforce the submarine, and the nearby volcanically active caves should even have the necessary input elements in sufficient quantities. The submarine manual contains instructions for finding the optimal polymer formula. I remember we had a puzzle like this in 2020, didn't we? It offers a polymer template and a list of pair insertion rules, your puzzle input. So let's get that set here. We're going to day 14 and paste. All right. The first line is the polymer template. This is the starting point of the process, so NNCB. The following section defines the pair insertion rules. A rule like A, B to C means that when elements A and B are immediately adjacent, element C should be inserted between them. These insertions all happen simultaneously. So starting with NNCB, the first step simultaneously considers all three pairs. NN, NC, CB. There's a rule so C is inserted. There's a rule so B is inserted. And there's a rule so A is inserted. Note that these pairs overlap. The second element of one pair, yeah, I got that. So we're going to do windowing, I think. Because all pairs are considered simultaneously, inserted elements are not considered to be part of the pair. Got it. After the first step, the polymer becomes NC and BCHB. Here are the results of the first few steps of the above rules. Polymer grows quickly. After step 5 has a length 97. After blah, blah, blah. Taking the quantity of the most common element and subtracting the quantity of the least common element produces this number. So that's the test answer. So there's 10 steps. That means we're going to have a constant. Const steps. This doesn't need to be, this doesn't need to be public. U size equals 10. So we're going to run it 10 steps, and we're going to find the most common and subtract the least common. So I'll probably just want to track in a binary heap. Actually, not a binary heap. Well, two binary heaps. The smallest and largest quantities, right? So apply them. What do you get if you take? Okay, so let's do it. So kind of like what I was just doing, I'm gonna first say let the lines equal input.lines map line.trim. And then we're going to get the first, well, step 0 polymers, right? Lines.next.unwrap. And then we know we're going to have a blank line after that. So I can just do lines.skip1. And then after that, we're going to get the rules, which we're going to reuse. So let's just say let rules equal lines dot map line to so I'll want like a rule type, so it's like pair, I guess, pair string. And then, actually, I guess we could make that 2 characters. Why not? And then it'll be the, the insert? Okay, so then how do we map this line to a rule? We take that line and we're going to want to split on the arrow, right? So line.split once on space arrow space, and then map that. Well, map and then unwrap, right? So mapping that, we get 2 things left and right, right? We get the pair and the insert. So we just want a rule where the pair is pair 0 to including 1, and the insert is the insert character. It's going to be one character, so insert dot chars dot next dot unwrap. I guess I can just... Okay, I can't do that either, because it could be Unicode. Who knows? Chars take... let's just do it this way, because I don't know how to do this elegantly. Let, so, let chars equal, well, pair chars, and then let left equal pair next unwrap, and let the right equal that, and then pair is just left right. Okay. And then what did I do wrong here? I've misspelled unwrap. And I didn't finish this up. Okay, we get our rules? No, lines is not right because I need to mark that as mutable. Okay, cool, but we got it. We got the rules. I didn't collect it though. Collect it into a vector of rules. We don't have to say rules though. We have vector of rules. And what's wrong with this? I moved lines somewhere. Where did I move lines? Oh, right here when we skipped. I guess we just called next once. There we go. I think skip is you wrap it into another iterator that skips one. I could actually just build it into this, right? I can just say skip one. There we go. Hey there, TS Jost. Have you already finished? It's 7 minutes. The top 100 probably already have finished. I have just finished parsing. This one is going to get annoying in part 2. You think so? I've just done the parsing alone. So, done the parsing. Now, I just want to run 10 times, right? So, for... And it doesn't matter what step we're on. So, for blank in 0 to steps. We want to get a new polymer from the old polymer. So, let... Well, polymer equals polymer dot windows, oh, chars windows 2. Like, do we need to, no, that produces an iterator, right? And windows 2 doesn't like that. Is it window 2? I forget how this works. I should qualify that. I should say within my RS files. Oh, is Windows only on a vector? Oh, right. It has to be on a vector. That's what it was. So I need to collect these. Collect. And then Windows 2. And then fold, right? No, map. We'll get slices, right? Yes, we'll get slices. So like pair and two horizontal. So hit enter. At the end, we're going to... Oh, that was a slice to begin with. Actually, why don't we just do chars collect up here. And then I don't need to do chars down here. I can just do windows on them. I like that better. And then that. Okay, so then what are we going to map it to? We want to split the left and the right. We want to actually do the same thing I did here. So I ought to just make a function that does this. So let's do that. Function make pair from a slice of characters, right? So chars will pair that generates a char 2. And then actually yeah, I'll just build the chars in there. So I need that line too. And then I just return left, right. Okay, and then so I can just say here, make pair, and remove that. Okay, and then so in here, let pair equal make pair. To do, we're not done yet. Actually, I can fill this in when we're done. When we're done, what did they want? Oh, right. This side, we want the side effect of counting the most common and least common. So I need to like have two, one thing to track the most and one thing to track the least. So I'll need to track all of the ones as we're going through anyway, right? How am I going to count them? I guess we can do it in between steps. Should do it at the end, I guess. No, I only need to do it once at the very end. Yeah, so I can just fold them into a vector of counters. Yeah, at the end I can say, can't even think how to handle this simultaneously and overlapping, growing exponentially or something. This is going to get annoying. Yeah, I read that part already. Not going to be a whole lot of letters. That's the fortunate thing. Let's say we're going to have a bunch of counters based off of characters, right? So I'll just do the lazy approach. Counters. And sort them and take the first and last. So this is going to start out as a hash map. Hash map. Actually, I can just boil it in. I can bake it in. I can just say it's polymer dot map will fold hash map new counters comma char what are you gonna call it? What is an individual thing called? A chemical element. And that's all I need. Well, hold on. I want to map that ultimately to a vector and then sort them. So, hold on. So map. Well, no. After I get it, I want to iterate them and then collect them again. So into iter and then collect into a vector. And then we'll counters dot sort unstable by a comparison function, and it's going to be like element count. No, the sort is like left right or AB. So it's like a.0 is greater. I can't remember if it's later, less than or greater. It doesn't really matter because no, it does matter. I'll need to know which one is which, or else I'll get an it'll be the sign will be reversed. So b.0, right? Dot 1. The counter is the value. Okay, so hash map isn't imported yet. It doesn't like me putting a to do here, does it? I'll have to fix that in a second. The way we fold this together is we say at the end it's counters, and this needs to be mutable because we're about to change it. It's counters dot entry element or insert what is it, or insert with. See, I'm gonna lose the autocomplete because it's really confused now. I think it's like this, or I can't remember. Should look it up. Hash map entry or insert. I think just or insert 0, right? Yeah, or insert 0 plus equal 1. All right. Fold them into an iterator, collect them, then we get out, then we sort them, and it's going to be counters. See, I'm going to get it backwards probably, but it's going to be like the first, it's going to be the last. It's going to be the last minus the first, right? So counters of counters.len -1 minus counters is 0. That, whoops, that converted to a string. There we go. All right, it doesn't know the type because I haven't filled this in correctly. So for every pair of elements, I want to look up the rule for it. So, and when we find the rule, we want to find the insert. Right. And ultimately, we want to zip this up, right? So like they gave an example. Right. We're going to zip the original characters. Actually, you know what I can just do is take the left and the insert. Left, insert, left, insert, left, and then right at the very end. So I do need to get the rightmost one. Last or something. Polymer length -1. Because we're going to want to chain, well, cares. No. I guess I can, what am I going to output here? I could just build it up again. It's the best way to do this. What did I like about pair here? Found reference to characters. Oh, is this already a slice of characters? So then I don't actually want that. So I don't actually want to make pair there. It's pair 0 and pair 1. Okay, but one step at a time. Let rule equal rules dot. Actually, I don't want to collect into a vector. I want to make it into a map so I can quickly find a rule based off of a pair. That's what I want. So this should be hash map. I have to map this one to actually just hash set of rules. I just have to implement how do we hash a rule, right? Equals and hash has to be done for rule. Yeah, we can just auto derive equal and partial equal. Actually, there won't be two rules with the same pair, so I can also automatically implement hash. That makes it easy. Okay, so now I got my rules as a hash set, so I can do rules dot get pair unwrap. That gives me the rule to follow. Borrow that. Oh, right. Shoot, I can't do that. Get requires what exactly? It requires something that hashes... Okay, so I do need to implement hash, because I want to hash on the just the pair. I'm surprised that... I forget how this queue is defined. Oh, right. That you can borrow it as a queue. T is the key. The T implements borrow of... Okay, so then we need to do that. Implement borrow char to for rule. Does it know what borrow is? It does. If I do that. So then I just need to borrow that. Cool. So now I can do that. I just need to implement this. How do we borrow it? We just borrow self.pair. Okay. So now we can look it up by just the pair to get the rule, and then we're going to output... this is the thing. What do I output? I need to output the... If I collect the last, then I need the first of the pair and then the insert. But how do I output them? Maybe it is an iterator and I just flatten it. So something like chain with standard iter once last flatten. And then collect. So then this would output the two things. So standard iter once pair dot 0 and chain with standard iter once rule dot insert. Okay, I can't get the 0 here. Why not? No field 0 on... Oh, right. Use an index. There we go. And I can't chain with that because I didn't close that. And then this chain doesn't work because I probably got the references wrong. It is an iterator of characters. Why doesn't this one work? Last is also a character. Why can't I chain that together? Type mismatch. Expected character found a chain... Wait, what? Is last not a character? Last is a character. Why can't I chain these two iterators together? I don't get it. Expected character found found a chain that returns two iterators. Why is it expecting a character for... Where is it expecting a character? I'm gonna get more help here. Cargo Clippy. I don't get that. Hello, King Cold. Run cargo and get error message. That's what I'm looking at. Yeah, I must have just like maybe done a syntax error here. Hold on. Let's pull this apart, right? Let x just be the iterator, And then we'll say iterator chain. What does that give me? Oh, it's an iterator of iterators. That's wrong. I want to flatten it right away. Flatten and then chain and then flatten again. Okay, that's weird. Let y equal that. Oh, I don't need to flatten there. Just collect it. Okay, cool. Then we got it. So remove the lets in here. Just do that and do that. Okay, so windowing function at 2. Then for every pair, we look up the rule to get the insert, and we take the left of the pair and the insert, chain those together, flatten those all together, and then chain the last one on the end to that. Collect that. We do that 10 times, and then Polymer is still a vector of characters, right? So at the end, why doesn't it like my fold? Oh, I need to do into iter. Oh, wrong place. Polymer into iter. Why can't I fold it? Oh, the closure is supposed to take 2 things. Oh, right. Instead of a tuple, we just take 2 things. There. And counters is a hash map character, so I need... What's wrong with this? Oh, I need to dereference there? Okay, cool. And then, why can't I unstable? Takes 2 distinct arguments. Again, left, right. Not a tuple. And I can't do that because it wants an ordering, not a bool. So I need to do like compare with that. And that needs to be borrowed. Okay, and then what do I get out of this? Why can't I subtract? Because they're characters. Oh, I need to get their counters. Shoot. The counters is the wrong type. No, the counters is the correct type. But I need to get the dot ones out of them. Then subtract those. There we go. So let's run it on our test input. Failed. Unwrap a none on line 56. Also, we ran into a rule that didn't exist. So let me make sure my rules are correct. So let's, I don't know, debug all that. See what we get. Why didn't it like me doing that? Okay, I'll just do it with a print. Rules. Oh, probably because actually I could have done that. I just need to make my rule thing debuggable. Right? That's probably what it told me. I just wasn't patient enough. Yeah, rule doesn't implement debug. We can fix that. We just say derive it, please. And now it will work. Run that test. I just want to make sure that the rules are correct. So what are my rules? So we get HB to C. And then NH to C. Where's NH? Here it is. They're going to be out of order. They're going to be in a weird order, right? BB to N. Yep. BC to B. I mean, they look correct. So I think my rules are correct. I guess my rule lookup is not working. So take out the debug on the rules, since they're probably good rules. So I think what I'll do is we'll just debug the pair right before we look up the rule and see what's the last one before it crashed. Last one was N. Oh, it's the very first one, NN. It couldn't find the rule. So it could be that my hash is wrong. Oh, it is wrong. I forgot. I can't just derive hash anymore because that's going to include the insert in the hash. Yeah, we have to implement hash for rule. We only want it to hash the pair. Otherwise, it's not going to hash the same as this, which it's a requirement of that. It's standard hash, right? Actually, I hate doing that, so I'll just use it up here. So I can do that, and then not derive it. Control dot, implement missing member. Okay, so then, yeah, what we do is we just drop this line. What's the error here? I don't... Okay, it doesn't want me to derive partial equal. Fair enough. We'll do that. Probably because it has to all be consistent, right? Alright, so we're just dropping the insert one off there. Cool, let's try again. Okay, it passed after printing out a lot of junk that we don't need to print out anymore. Let's remove the printing. And I messed that up, didn't I? No, that was correct. Yeah, okay. Don't mind me. I'm just, you know, I have glasses. Sometimes I forget to use them. All right, so let's just run it on our test input. So run 14.1. Panic on 56 again. Oh, did I mess this up? I did. Look at that. No, that is correct. Do I not have my 14 input? I don't. I never fetched it. Fetch the input. Store it. Run it again. 2,509 is the answer. First try? Of course the first try. I think I've only messed up once or twice. The char semicolon 2 doesn't hash the same as rule. Yes, figured that out. Yeah, equal and hash must be consistent for most. Yep, got that. First try, yeah. Let's do part 2. Because time's wasting. The resulting polymer isn't nearly strong enough to reinforce the submarine. You'll need to run more steps. A total of 40 should do it. Okay, so this is easy. We just increase the number of steps. Quickly now. 14. I just go to 20. I'll take the time, even though it's silly, to separate this into parts. So I can put part 1, part 2, and this, they want 40, right? So we use the part... So this is steps part 1. So part 2 is the same, just a different number of steps, right? So I hate copy pastaing, but let's just do it for the sake of time. We'll clean it up in a minute. What they said is with the same input, I get a much bigger number for the answer, right? So... is this where brute force falls apart? That's a big number. Run it. As I cringe. Oh yeah. It's taking a lot longer. Okay, I guess I can let it keep running. Yeah. I guess brute force isn't going to work. So I had to think of a more clever solution. Yeah, I mean, we're gonna run out of memory, I think. Control C out of that guy. Yeah, I think we can't store it as a string here. Because the string is going to get extremely long, more than we have memory for. Yeah, it should finish in less than a second. It's just that I'm storing it back into memory each step. So how do I do this without storing it back into memory? I mean, when we store it, we end up just when we loop around, we just take the last and run it again. So maybe I can think about this in a better way. Okay. So maybe think about how this expands in a way we can see some patterns. Like if we know nn goes to ncn, then we know really nn goes to an nc and a cn, and we can collapse that, right? I wonder if I can just have it like expand the rules 40 times to a bunch of counters or something. Do you need to keep track of the positions? No. Is that a hint? Probably. Yeah, I see where this is going. If we know nn goes to c, then we know really nn goes to an nc and a cn. So I can have all the possible pairs that come out of each pair and then just count pairs, right? And at the end, we'll just have a count of how many NBs and BBs and BNs we have without having to keep track of where they are. Right? Because this becomes 1 NN, 1 NC, 1 CB. And so there's just 3 different counters. Well, we'll end up with this. We'll end up with this many counters, really, right? And just we'll be convolving those counters every loop. The lanternfish problem, is it? The lanternfish problem was a rotate with a feedback point, spaced repetition. Would Eric be so bold? It doesn't seem like a feedback problem to me. It seems more like a block against brute forcing it with memory. So let me try the approach where we count the actual combinations, the pairs first. So actually, I can do that with the part 1. That would be faster. Let's redo part 1. Because if I screw it up, it'll just be wrong faster, right? Or I don't know, it doesn't really matter, right? If I do it correctly, it should just work really fast. But if it doesn't work correctly, this one, it doesn't really matter. Let's just do part 2. So the rules are all parsed the same way, but I don't want a polymer, actually. I don't want this to be collected like this. After I get the chars and collect them, I need to Windows that. Windows 2. Hold on, it's off the side of the screen there. Windows 2, and then kind of like this, right? This one. Map each pair to an array of size 2. And then I think we just want to fold that into a hash map of counters. So let's just map the pair to an array and then fold into a hash map. So we have mutable counters. Well, polymers. Counters, polymers, I don't know. Pairs. I like the word pairs. Pairs and pair. And we're going to end up like that. So it's pairs dot entry pair or insert the value, which would be a 0 plus equal 1, just like we did before, actually. Where did I do that? Right up here. Oh, right, when we were counting at the very end. Only I'm doing it with windows and counting pairs. So, I don't want to... Wait, what? Tend to take value of method collect on chars, use parentheses to call the method. Yeah, I forgot the parentheses. And I just mistyped them too. Alright, so this is almost right. I forgot to dereference. Oh, it's, I guess or default is what we want, really. We want it to be that. It's unknown because it doesn't know the type. I guess I could give it the type. Anyway, this is the rest of this is wrong at this point, right? Should I just drop it? This is not what we want. I can pull what I want from part 1 if need be. But after we convolve it, it's just, I think I just apply the rules again, right? Yeah, so we'll end up like with a map of counters from rule to we'll have a map from rules to counters, or pairs to counters, basically. And the end string will be we multiply each of those counters by what? No, sorry. I will go through the rules and pick the individual characters out, multiplying by the value in that position in the map. And I have to also, so it's the each character in the pair. No, it's not each character in the pair. It's the left one in the pair, and then the insert. No, well, hold on. I need to know which one's first and which one's last. That's the wrinkle in this, right? Oh, we know which one's the first and which one's the last. They're constant. Okay, so I won't regard the first or the last. Actually, I guess I'll just... We know what the last is because it's the last of the original template. Yeah. So it's just the first and the insert multiplied by the value in the map. For every rule, and then add the last one at the end. Okay. So, I'm going to put this into code now. The counters are still by characters, but how do we get these counters? It's not by pairs anymore. It's just by individual characters. Yeah, so I'm going to fold into a hash map to characters, so... Yeah, this day, what are we on? Day 14 is definitely hard. At least part 2 is throwing me for a loop. So it's not element anymore here, right? It's actually, what's wrong with this line here? Annotations needed. Oh. Sure, what if I just say hash map char to usize. There, now it knows what it is. I can probably remove that turbofish later. Turbofish are there to prop you up until you're done. Okay, so difficulty. Too much cognitive load. Assuming I have polymer, it's really just a count of how many pairs we have. That's the intent. So then, for each, it's not an element, it's a pair and a count. I'll want to, right, I know. I want to take the count and add it to the one for the left and the insert. So counters dot entry pair dot zero, pair 0 or default plus equal count. Counters dot entry. Where's the insert though? Oh, we gotta look up the rule. Rule lookup. Here it was. Where was I? Down here. So it's rule dot insert or default plus equal count, and then drop that line. What does it not like about this? Oh, I need to dereference in both places. And it doesn't like this because it needs type annotations. So I think once again, I'll just use the turbofish for now. So this is from character to usize. Okay, it's happy with that. I just need to do the iteration. So for the iteration, we want to turn each pair into 2 pairs, right? Yeah, so NN becomes NC and CN, and then NC becomes NB and BC. So each pair becomes 2 pairs, and then, yeah, isn't that right? So it'd be, for, what is it? I just need the keys, right? I guess I can just clone the keys. So let, what are these called? The pairs called? I'll just call them pairs. Let pairs equal polymer.keys.clone. Because I'm going to be like inserting new keys in there. We can't do it while we're iterating the keys, right? Collect actually, because that returns me an iterator, right? Collect into I guess it could just be a vector. So then we get a vector of pairs. So then after we've gotten the pairs, now we're going to consume them. Actually, then I don't need a name. I can just say for pair in that into iter. Why is it still borrowed? Oh, I need to copy them. Yeah. Because we want to divorce it from the original polymer, basically. Then for every pair, we need to look up the rule to find the insert, and then we form 2 pairs out of that, and then we look those up back in the polymer and add 1 to both, I think. Actually, we need to subtract 1 from the original pair because that pair goes away. So that's the first thing, right? Polymer dot get pair dot unwrap. It's get mute actually, right? Minus equal 1. That. And then we add 1 to the 2 pairs that we get when we apply the rule to it. So let's get the rule out. So we get the rule, and then we do this twice where we add plus equal. Well, and I hope I'm doing this right. So it's instead of pair here, it's pair.0 and rule.insert. And for here, it's rule.insert and pair.1. I think that's right. What's wrong? Oh, I keep doing the dot, and it's really index. Dot is for tuples. Index is for slices and arrays and vectors and stuff. Is that right? Getting bugged by OC now. Hey there, scripter. How are you doing? Rust looks like TypeScript. I guess, you know, Rust is sort of a mishmash of syntax from a lot of different languages. If you learn enough languages, you sort of get that there's it's almost like there's an underlying like set of principles that are expressed in certain common ways that then you can map to the syntaxes of individual languages. So like the concept of a loop, a statement, a function call, you know, stuff like that are fairly common between languages. Some languages are more exotic and don't use this typical conventions, but this is close enough to other languages where you can say, yeah, this reminds me of TypeScript, only it's like weird in certain ways, right? More verbose than TypeScript. Well, that's probably because a lot of the syntax is required to make the types all static at compile time, like known, like distinct. Is that the right word? You can't be loose on the types. You have to be. It's very strict. Okay, so then I'm just wondering if I got the answer here. Should I just try it, or is it totally wrong? Failed. We unwrapped a none at 129. Oh, right. We have to use entry. Sorry, I need to use entry. Entry of that, or insert, or default, I guess. Yeah, entry or default, and or insert. There we go. And yeah, it needs to own the array, because it might potentially store that in the map. Okay, try again. Panicked with attempt to subtract with overflow. Okay, so that can happen if it was a 0 and it goes negative. So maybe my logic's faulty. Let me run through it manually. So let's at least debug the first polymer. See that? See that I constructed that correctly? Here it is. An NN, an NC, and a CB. One each. NN, NC, CB, one each. Okay. Got that. So, I'd like to see that on one more loop to make sure I got the second part correct. So, hold on. Can I say, like, can I give this an I here? And say if I equals 1, then print line after 1 steps polymer is, then debug it. Let's do that. I need to put I there. Run it again. Just want to see if it's doing it correctly, because it gave us what it is after 1 step, right? Okay, after 1 step, it's BCCN. That's wrong. There's no... Oh, no, there's a BC there. Right there. There's a BC. There's a CN. There's an N. There's no NNs anymore. CH is there. NC is there. CB is... CB is 0, not there. HB is there once. And NB is there once. Okay, it looks good to me. So should I just, I should just have it print out all the steps. So get rid of that if. And we'll see where it went wrong. Where did it go horribly wrong?
Okay, now you can't hear me over the dog. I don't think I have your Venmo.
It failed on the very next step. So I'd like to know what that was. So 128. I guess we'll put in a check here. Let pair equal that. And then put pair. If pair equals 0. Panic. Oops. Is 0.
Okay, well, what if you had a blinking
Pair. Do you reference that? Oh, I have to call it something else, something different. What to call it? Polymer entry. It's pair count, right?
She does so much damage.
Hold on a second. I need to hydrate. I need water. Okay, run it again. It's all just like debugging various things that I got wrong in the algorithm. 0 is 0. That's not what I wanted. I wanted the pair. I wanted the pair, not the pair count. Okay, try again.
Can I flash the kill? I'll have to.
NN is 0. Where did it see an NN? Oh, we want to skip those. We don't want to split them again because they're not present. Oh, the other thing is, I don't want to just subtract 1, right? I want to subtract the count and then add the count to the other 2. Okay, so I had 2 mistakes in there at least. So, we just want to remove it and then add its count to the 2. So, yeah, I don't want to just get mute. I want to remove. I want to remove the pair count and then add that pair count to the other 2. That's what I want. Okay, let's try this. Okay. It ran really fast. It just got the wrong answer. Now, did it get it correct after, like, they gave us 10 steps, or they gave us 4 steps, right? I actually don't know how many. It's hard to see. But we know that after 1 step, it was correct, because I checked that, right? What about 2 steps? Okay, there are 2 CBs, is that correct? CB and CB, yes, they're 2 steps. Oh, and the other thing I forgot is I forgot to add the one at the very end. We're not counting that one yet. But I'm not off by 1. So there are 2 CBs. There are 4 BBs. 1, 2. Okay, that's wrong. That messed up somehow. How do we get 4 BBs? Okay, go back. CNNNCB. Or NCNN and CB. That's correct. After 1 step, is it 1 HB? Yes. And 1 NC? Yep. Debug a step-by-step, run the debugger. I hardly ever run the debugger in Rust. Because what I'm doing is usually sufficient to... I usually just find out what I did wrong pretty quick. 1 HB, 1 NC, 1 CN. That's correct. A BC and NB. A BC and NB. And an H, a CH. Okay. So how did I get 4 BBs for 2 steps? Because there's not 4 BBs. There's only 1, 2. That's it. So we got an NB, and we got. Where did it find? Is it because there are 3 sequential there? So where did that happen exactly in the original sequence? That's an insert. That's an insert.
Can I power dive as Renekton? I don't.
That's an insert. Okay, there are 2 inserts. So there was between the NB and the BC. This NBC becomes NBBBC, right? So NB should have removed 1 from NB and added 1 to. So NB goes to B. No, NB goes to C. No, NB goes to B, right? And CB and BC goes to B also. So those both insert B. So what should that have done? It should have removed NB and then added it back with 1 again. And then it should have added BB with 1. And then we should have removed BC and added 1 to BB again, so it should have gone to 2. And then 1 to... So why did I end up with 4? Do I need to, like, debug those subtract and insertion rules again? Because I think that's the key that I did wrong there. That should not be a 4. Oh, you guys can't even see it because it's off the screen. I'm sorry. I can't even show it. It says BB4. My apologies. You guys couldn't even see it. Okay, I guess I'll look at the code. Maybe I should use the debugger, huh? Maybe you got a point there. So it should have removed... where is it? Oh, I deleted it already. It should have removed NB and then added that original pair count, which was 1, to NB and then BC. Or NB and BB. And then the next one around, it should have removed BC and then added another one to BB there. I think what we'll do here is just print it out. Removing, adding blank to blank. I don't know why I typed that twice. I need that there and that there and pair count twice. Okay, and then we'll just let it go only 3 steps for now. Because there's going to be a lot of printing here. Okay, here we go. So, how did BB end up with... Oh, now it's at 3. Wait. But it's still wrong. It should be 2. Anyway, 1 to BB. Why did it add 1 to BB? Oh. Removing... Oh, it's doing it in a random order. Oh, okay. I need to do them in order. Shoot. Okay, so this is wrong. I can't do them in a random order. Yeah, that doesn't make sense. I have to produce a new set of counters every time. That's what I gotta do. Yeah, okay, so this remove is bad because the remove and then the entry could overlap, and then we're doing them in a random order. Okay, then we're just gonna have to form a new one every time. So that means I don't really need to do this keys copied collect into iter. I can just say into iter, and then for pair and count. And then we don't need to remove. So I'll remove that for now. Yeah, but when the one we want to collect, the one we want to form is we want to fold, right? So that means I want to turn this around. I want to say polymer into iter fold, and we're going to store it back into polymer at the end. So polymer is hash map. Yep. So new, and then mute polymer, and then we get pair and count here, like that, and then at the end we put polymer, and then close that off and do that. Okay, so then this is just count. Where's count? Here's count. There we go. Let's try that. I'll eventually get this, you know. All right. NB is 2. 1, 2. CN is 1. Correct. BC is 2. So it's 1, 2. Yeah. HC is 1. So there's the HC. CC is 1. BB is 2. Yeah, that's what it should be. 1, 2. CB is 2. CB, got it. And then BH is 1. All right. So we're comfortable going all the way, and I need to remember to add 1 for the one on the end. Or else I'll be off by 1. Actually, we can just see the off by 1. So make this 40. And I mean, I guess we can print them. That doesn't hurt. Let's just run it. I'm not off by 1. Something else went wrong. Was it 40 or did I get the number wrong? It was 40 and it produced that number, but I got one that's like twice as big as it should be. It was doing third when you were watching 2. Watching the wrong line. Today's annoying. I mean, it's not that annoying. But did I screw this? Is this still wrong? Well, ultimately I can count the number of, well, hold on. I think I'm counting the wrong things actually. So at the end it's we're not printing out that final calculation, so let me do that. And reduce this for now to like 3. And debug this. Run! Okay, so at the end we get 22 Bs. This is after running it 2 steps. Oh, do I have number of steps wrong? I might have the wrong number of steps. So if we ran it exactly twice, 1, 2. I think our counters are way off then. How many should I have gotten? 2 plus 2, 4, right? 1, 2, 3, 4, 5. Why am I off? 2? Oh, 2 plus 1 plus 2. And then there's the one at the end. Why does it say 22 though? Oh, I went too far, I think. Hold on. I think I'm off by 1 in the number of steps. Oh, shoot, I had this wrong. We actually went 3 steps. Run that again. Yep. So it's after Did I do that wrong? Why does it still say 0? Probably because this should say 1, 2. Add 1. Focusing on the wrong thing. I should have just ignored that. 1, 2, 3. 5 H's in this mess? 1, 2, 3. I only count 4. 1, 2, 3, 4. Yeah, why did it count 5? I think my counters are wrong. My counter logics must be wrong. Let's look at that counter logic again. So it takes the left of the pair. Oh, yeah, this is wrong. Why am I folding? No, okay, no, that's correct. I am supposed to fold. But, the left add the count, the insert add the count. Why do I keep doing that? I keep closing the output. Let's do something easier to count. Just do 2. Yeah, this is going to kill my time for part 2, but that's okay. Okay, 10 B's. That's not right. To the 1, 2, 3, 4, 5. There's only 5 plus 1. H's. There's only 1, not 4. Why is it counting 4 H's? Oh, 1. No. Oh, it's not showing the insert. That's the problem. Oh, I'm not supposed to apply that insert rule again. What am I doing? I don't want to window this at the end to get the counters, do I? What am I doing? I think I was leftover code in there. I don't want to do that. I just want to do that. And I have to add the one for the last character. Why don't I just throw that in there now that I'm there? So, like, counters. Entry. I guess we'll just do it the same way. Counters dot entry, and then I just need to know the last character of the input. So I need to know the original input, the original polymers. So I need to break it right here. But between that, I need to say, like, let last equal polymer dot len minus 1. And this doesn't need to be mutable anymore. Okay, so then I need to do last or default plus equal 1. Oh, it's a vector at that point. I want to do this last then. So let mute counters equal counters into iterator, and because that's a debug. What did I do wrong here?
Wait, she did. It's 700.
Counters. Remove that. There we go. Okay. So then I guess I want to debug at the very end. Alright, let's see what it is. God, so many mistakes this time. Okay, that looks better, right? After 2 steps, we have 1 H. We have 6 B's, 1, 2, 3, 4, 5, 6. We have 4 C's, 1, 2, 3, 4. We have 2 N's, 1, 2. We have 1 A. Yeah. Okay, so just increase it to 40 now. And we get the answer, I hope.
Okay.
Close that. Go to 40.
Looks like he has
Run it.
around the cigar.
Yeah, finally. Okay, so then let's run this now. Oh, that was part one. We need to run part two. There we go. We got a number. And it's the right number. Finally. So now that the pressure is off for time, I could probably redo part one to do the same kind of thing rather than accumulating it in memory.
That's what I mean, Zach. That's
Right? So part two is the same as part one, only the number of steps is different. So I should be able to take part two's inner. For now, I'm just going to copy it because I'm lazy, but probably just put it in a common function.
Where'd he go?
Insert.
That's not the.
Did I just do it wrong? I just did it wrong. Copy. I'm hitting the wrong key chord for paste. That's what happens when I get tired. Paste. And it's steps part one. So I should get the same answer for test part one as I did before. Yeah. Oh, I can remove the debug now.
Wait, CJ, if you can.
So run my test part one. It's still printing out stuff. Oh, I had a print line.
Dude, I'm cracked.
Pass and pass. Okay, so then let's get let's bench it. Cargo bench
I dropped off.
14.1.
I'm tired.
What did I do wrong? Oh, I probably didn't update the benchmarks.
So you have to have.
Yep, I forgot. 13 and 14.
Yeah.
13, 13, 14, 14. What are those other warnings that I was getting? What warning am I getting?
I don't know.
Oh, I didn't need I anymore.
In the middle of fights and with her neck.
Okay, part one is 122 microseconds. Part two is going to be longer,
This game, every single
but probably not that much longer, right?
push all the wrong buttons.
Probably like
That's what I mean by always.
a millisecond or less. Around a millisecond? Half a millisecond, 480 microseconds. How are you doing? How did you do, TS Just? Did you solve it yet? You probably solved it like an hour ago, right? Every pair overlaps the next to a double, yeah. Because I still had that logic from when I did it the other way, I just needed to delete it.
I attack her.
You haven't finished yet? What? Come on, TS Just, you can do it. Just finished making a memory efficient thing. That's what I just did. You have to make it memory efficient to solve part two. Is that my giving you a spoiler by saying that? Now you need to do the max minus min thing. Okay, you're almost there then. That max minus min thing is really, what am I trying to say? The max minus min thing shouldn't be that big a deal if you have done the memory efficient thing. Okay, I got rid of my warnings. I still need to finish part day 13 though. But before I do that, I want to see what my scores are. How are my scores? Personal stats. Yeah, worse than usual. Actually, it looks like a lot of people finished part one really quick.
We're back at it.
That's interesting. So even though I took a really long time for part two, I caught up to everybody. Or people haven't solved, or people got stuck on part two. Is that what that tells me? That a lot of people were faster than me on part one, but then either they got stuck or they didn't even try part two yet. Hey there, Endurin. How are you doing? You ran with the test input? You can do it, TS Just.
I need those. If you don't,
That often happens with optimization problems. Yeah. I thought I did pretty well on part one, but maybe I'm just slow. I was hoping this is the rank I'm hoping to get, between 2,000 and 3,000. Because like day 1 and 2 sort of calibrated how fast I am compared to everybody else in my mind. that I should get within that rank. And now, like, I did that again on day 11 and day 9. These other days, like, I didn't start on time there or there or there. So they don't really count. This is my good day, day 5.
Really, as soon as I died.
And this is the day I fell on my face. And I think I fell on my face on 8 as well, if I remember right. And 10 I didn't do so well. Actually, no, 10 I started an hour late, I think. That's what it was. Like, I would have gotten 14 minutes and 23 minutes. Anyway, I haven't done the unlucky one. Let me do the unlucky one. All right, the folding. Let's go back to the folding problem. Where was I on the folding problem? Oh, right. I had made the functions. I just hadn't filled them in. So folding horizontally.
10 and 6, that's not even anything special.
Okay, I don't like these names already. This should just be fold. Let's call this horizontal is really... I think it's confusing. I think if you give it a Y position, that's folding up. So this should just say up. And that means this should be left. Right? That's easier. Fold up or fold left. Right? So then fold horizontally is fold up. And vertically is fold left. That makes more sense, right? So then folding up would be... We need to first find the holes that are below that Y. So holes dot iter dot find or filter map XY. If Y is greater than, well, let's make this one called like fold Y. If Y is greater than fold Y, then we want to return some X, and then it's going to be like mirror it along that fold, right? So it would be fold Y minus fold Y. What is that? That's fold Y times 2 minus Y. Right? So then I can turn, if the else is none, and then we're saying that let this, well, let's collect into a hash set. New holes equal that. Then consider, how about I just do this little trick? Haha. Oh, you can't do that? Shoot. Wait, you can probably remove the explicit borrow Y. Oh, I thought I could do that there. Yeah, I just need to dereference wherever I do that. And I should dereference in these places as well. Otherwise, actually that's the only place I need to dereference. This one it automatically dereferences to do the subtraction because I get the right size at the end. Okay, I was gonna say like I can turn that into
It's the one
a then. Then
that one.
this,
Just tilt it.
right? So I'll put it on one line. It looks nicer if I turn off the inlay hints. Filter map XY, Y greater than fold X, then do this calculation. And return that. Otherwise, drop it. So then I need to combine them back in. So this would turn into... I do have to collect it, but then I can turn it into an iterator again. And do a for each. So for XY in those.
Oh, it's smited.
Holes.insert xy. I think that's probably the easiest way to do it. Then fold left would be very close to the other one. So it's if x is greater than fold x, then it's fold x times 2 minus x, comma, dereference y.
Against monsters.
And let's see if I got it right. Test part 1. Nope. I had 38 holes instead of 17. Okay, I did it wrong. How am I going to test that?
No, it's just not fun to look at.
I don't know how I'm going to test that. Maybe just by printing the result.
I'll give you feedback.
So, like, debug that holes and see what it is.
I don't
What did we get?
know.
It's hard. This is going to be hard to see, isn't it? It's going to be really hard to see. It's, we should have gotten that, but we got this instead. I don't even see 0, 0 in there. Did I do this right? I don't think I did this right.
If you can hook the support, that works.
The second one was
Support items.
x5. 0, 1, 2, 3, 4, 5. So 6 should have gone to 4, right? So did I do my math wrong?
Bordered or all not bordered?
Yeah, that debug didn't help. Did I do my math wrong for the fold left? So the fold at 5 times 2 is 10, minus 6 would be 4. That is correct, right? 6 goes to 4.
So you just earn money by hitting minions at half health.
You have to see it for part 2. Uh-oh.
Only when you have settings, which you'll see right above on.
I'm thinking of just
So you have
making a custom debug for this that actually plots that like
you
that.
have a number there, you could
That might
hit a minion that's
be easier to see.
X
Um,
you would hit the
Problem is I have to add extra code to know like the limits.
offline. This is the best whatever.
I wish I could just see the bug here. Greater than the fold.
Dog.
0, 1, 2, 3, 4. I should maybe just print out what we're folding. Folding up at
You'll
fold Y. Folding left at X. Just a sanity check. Might as well make the debug, it won't be time wasted. Oh, you think so? Hint, hint. Folding up at 7, left at 5. Okay. Well, let's do the debug thing then. Because it sounds like we might need it. Which, yeah, to do that properly, I think I want to actually make a type for this. So let's do that. Struct paper. Hash set that. I don't like doing that kind of type. I'd rather do it this way. Holes. Okay. Implement debug. We can do display for paper. This needs to be well, I guess I can just do it this way. Control.import from format and then implement missing members. Okay, so I mean, we're not going to print it that much, so we might as well just do a brute force. So we let max x equal holes dot fold it holes iter fold 0 max max x x max x max x. And the same with y, right? Y.
figured something out. Not too good at Darius.
Oh, this isn't right here though. This is X and I don't care about Y, and this one's don't care about X and Y. Turn on the inlay hints. What did I do wrong? Oh, holes is self. Holes. Alright, and what's wrong with my X that needs to be dereferenced? Okay, and then so it's for Y in 0 to max Y. Whoops. For X in... Okay, this one we can just do a print line, right? We can say print that where that is self dot... No, it's just 0 to max X map, well, iter, into iter, map X into if self.holes.contains XY, then it's a hashtag, else it's a dot. And then all of that collect into a string. What I didn't like about that? Come on, come on. Oh, I need to do that? Oh, I don't want to do print line. Shoot, I want to do f dot.
Just make the singer look.
Isn't it for? I forget how to do this. It's like right line f comma, I think. Without
If anything, I have more
that. Is that how you do it? And then OK at the end? I think that's how you do it. Okay, what's wrong with my XY? Add reference. Oh, yeah. There we go. So then let's display the paper after each operation. Or how about the very beginning? No, let's just do it at the very end. After, well, let's just print it. We're calling it, I haven't actually used it yet. Let's do that. This is really paper. Is paper new? Well, let's just implement a default, shall we? And paper.holes. Call it paper. Change this to take paper. And then this is paper.holes. So now they're now all using my type. I have one thing here. This is paper.holes.length. All right, let's print it out. See what I did wrong. Oh, I can't read that. I need an extra line. Actually, I guess if we do print line, it'll add the extra line for me. Oh, it didn't remove the original holes. That's what I did wrong. Okay. Then... let me think about this. I think I just want to make a new paper out of the old paper by folding them all together. So let's first put this into paper so I can own holes. So impl paper. And then this is just self. Right? And these are all self. Okay, and then this is paper dot fold up. Better form anyway, right? I'll remove that. Okay, and then yeah, so I need to do into iter, and I don't want to do a filter map. I just want to do a filter, and then I want to do an if that's greater, then it's that, else it's just xy. And then I do that.
Page.
And then put that in front of self. Self holes equal that. Remove the 4. Semicolon at the end. Then we don't need to dereference anymore because we actually own those values. And why won't it let me do that? Yeah. Okay, I'm going to do a trick here. Watch me do this trick. We're actually going to own self. But we're going to return self. Alright, that makes self mutable. That's a devious trick when you want to move out of something that's in self and then move it back in. You can do that if you own it. It's just then now I have to turn this around and say paper equals paper fold up chord, like that. That's a devious trick that I figured out. So we own, they do the same thing here, I guess. Right? And return self. Alright, so then it's, if x is greater than fold x, it's fold x times 2 minus x, y. Otherwise that. And make it mutable. Alright, let's do this. Almost right. What happened? We cut it off somehow. Does that look like that? Oh, we're off by 1. How'd that happen? I don't know. What did I do? I messed up my paper somehow. That's correct, right? What did I do wrong? Oh, I didn't not printing it correctly. There we go. And there. But I still got the wrong answer, didn't I? I'm off by 1 somehow. How am I off by 1? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Why did it say 17? Am I counting this wrong? 5, 10, 11, 12, 13, 14, 15, 16. Why did they say 17? Oh, they're saying for the first fold. I didn't see this part. Focus on completing the first fold. Was the second one just going to say fold it completely and then count it? All right. I misunderstood the instructions. So I just need to hack this. I need to just say lines dot next dot unwrap, remove this part there. Just run it once, basically. There we go. I did it. So then the command is cargo run 13.1. That's a big one. 693. There we go. What's part 2? Just fold it until it's empty or something? Finish folding the paper along using the constructions. Manual says it's always 8 capital letters. Oh, yeah. I thought it might ask me that. So then, close that. Lower that. I got it. I got this. We just need to put my loop back in there and then print it out at the end. Okay, let's remove this print. Okay, then 2. We're not going to have a test for it. There's no test for 2. We just want to say 4 line in lines. Remove the next. And do that. And part 2 inner doesn't return anything. Part 2 doesn't return anything. There's no answer. We just print it. Let's do this. Oh, right. Because of the way I set up my main program. Actually, you know what I can do? I can have it return something. I can have it return this format. There we go. Put back the string. Oh, wow. Hey there, Adam. How are you doing? I'm just finishing up day 13 of Advent to Code. You're about to see me get the answer, hopefully. Let's see what the answer is. UCLZRAZU. UCLZRAZU. Yes! We did it. How did it go? We just got it. You missed all of my hard work over the last 2 hours. But yeah, I do Advent to Code. I've done this for a couple of years now. I'm doing it in Rust this year, and I did it last year in Rust. But thanks for the raid. What is Advent to Code? For those who don't know, it's an Advent calendar of programming puzzles. You can pick whatever language you want. You get 2 puzzles per day. They're Christmas themed. They're pretty corny. So like this year, it's here's the ocean on day 1. Oops, dropped the keys to Santa's sleigh. Now we got to get in our submarine and go down along the ocean bottom. Now we're in some caverns and all of this stuff. And each day is a new adventure contrived just to give us a programming puzzle. So today, the one I just did gave us like instructions for where to plot dots on a piece of paper, and then instructions on how to fold that paper together. And we fold once, we fold twice, and we get that, right? And the first part of the puzzle was just fold it once and tell us how many dots there are, how many hashtags really. They worded it a little strangely. They said dots, but when they said like, how do we want to show it? Well, hashtags are dots and dots are blank. I don't know why they did it that way, but anyway, we just count the number of hashtags. And then part 2 is, okay, fold it all, do all your instructions, fold it completely, and then tell basically what letters does that print out when you print it. So we just finished that. I did day 14 before I did day 13 because I did 14 right when it unlocked. These puzzles unlock at midnight Eastern time. So about 2 hours ago, puzzle 14 unlocked, and I did that in real time. And then I went back and did day 13. Day 14 was really hard for me. Part 2 was really hard, but part 1 wasn't too bad. They gave us a bunch of rules and an input string, and the premise behind this is that we're getting deep under the ocean, and we need to polymerize the hull of our submarine, and we have some instructions for chemical transformations to get the right polymer to help us survive in the depths. So take this input string, a bunch of chem elements, and then we go through these rules and expand them 10 times, and how many of each element do we have least and most of. So they gave us that for this example, here's after 4 expansions, and then if you keep going, you'll have like 1,749 B's and 161 H's, and you subtract the 2, and that gives you the example answer. So part 1 was pretty straightforward because you get a string that's like 1,000 characters. And then I tried my brute force solution on part 2, where you'll have a string that's so large you don't have enough memory to actually hold it. And so I had to abandon my part 1 solution and think of a way to solve this without actually forming the string in memory. And the solution I came up with is recognizing that there's a finite number of characters. In fact, there are a very few number of characters. And so if we just remember all of the pairs, and at the end, well, while we're tracking the pairs, we have a counter for each one. And then as we're expanding, we're not making a longer string. We're just expanding our counter set. So like we would start with 1 NN, 1 NC, 1 CB. After a step, we have 1 CB, 1 CN, 1 NB, 1 BC, 1 CH, and 1 HB, right? 1 each. But then when we get to step 2, we start to have doubles. So we have 2 BBs, we have 2 CBs, etc., right? And I had a lot of bugs in there. When I finally got the bugs out, it's a very quick solution with enormous quantities for the counters at the very end, like they're saying, like huge numbers. But computers can handle adding and subtracting huge numbers really well. It's just allocating that many bytes is a big problem. Just download more RAM. Yeah, how big is this number? So that's millions, billions. So 2. Am I reading this right? 2 quadrillion or 2 trillion? It'd be this many millions, this many. Yeah, 2.1 trillion bytes is what I would need to hold the actual string in memory. Actually, the a little bit bigger, because it's that many B's and then H's and C's and stuff like that. Anyway, it took me the longest time to work out all the bugs to that, but the solution is pretty quick. I like to solve them in Rust and then run a benchmark to see like how fast they were. So I did like cargo bench. We can benchmark 13.1 but not 13.2 because 13.2 doesn't. Well, actually, I could benchmark both of them, right? I have to write my benchmark a little bit differently, don't I? No, actually, no, I don't. The answer is just multi-line in this case. The benchmarker doesn't care. So the one I just did before the raid happened is part 1, 113 milliseconds. Part 2, we'll run that benchmark. So it's like running the solver lots and lots of times and timing it and then averaging it to figure out, well, how long does it really run? Yeah, so 239 microseconds. So, and I'm usually happy when I get sub millisecond, so that's pretty good. 2 terabyte if you type that right. Yeah, just get a 2 terabyte RAM and you can do it all in memory. Need 42 bits to store that number. Yeah. Definitely need 64-bit architecture if you're going to allocate that much memory. So yeah. So unfortunately, you rated me at the end, and we just solved it. I could spend a little bit of time cleaning it up so you can see a little bit more about Rust, the programming language I'm using. And you can see how horribly I wrote it at first, and then maybe I can refactor it to look a little bit better. So this is a unit test. You mark it with this attribute test. This is what a function looks like. This is what an assertion looks like. This is just an ugly function call where we're passing a huge multi-line string in, right? So here's the function that takes the string, outputs a string. Why do we have 2 things for string? The answer is complicated, but the quick minute is that capital string is one that you own. So you as long as you hold on to it, the memory, it stays in memory. It's on the heap usually. Whereas the lowercase str with that ampersand in front means we're borrowing. We have a pointer to someone else's string. We don't have control over when it gets destroyed. It's guaranteed to live as long as the function call, otherwise Rust wouldn't let the program compile. But we're not allowed to deallocate it. We're actually also not allowed to change it. If you put a MUT in between the ampersand and the name, then you're allowed to change the thing. But even if we were allowed to change this kind of string, this has another restriction where we can only change the individual characters in it. We can't add or remove characters. So the length is constant, even if it's a mutable slice, what they call a slice of a string. So let me turn this off for a second. This is what Rust looks like without the editor helping me out with what they call inlay hints. There's a lot of type inference. I'm not saying what the type of lines is or the type of paper or any of these other, especially in here where we have a chain of function calls. It's difficult to see what the types are of every intermediate step. So I like to turn on inlay hints. This is little gray text. So it says, yeah, lines is some implementation of an iterator where the item is a slice of a string. Fine. Paper is a paper. A line is a single string, etc. This kind of function chaining you'll see in a lot of functional programming. I like to think of it as an assembly line. So we first take our lines. We take the first line. We make sure that there is a first line, otherwise we crash. Strip prefix says it had better start with this string. Chop that part off, give us the rest. If we have something, then take that line and split it at the equal sign, and then map the result into, I turn the X and the Y into a direction, and the coordinate I just parse as a unsigned integer that's big enough to hold the size of something in memory. That's what usize means. Kind of like size t in C, C++, right? Matches are like switches in C. I think C# has switches also, right? Only there are a couple unfamiliar conventions, like underscore is like default. And you don't have to have constants here. You can actually have patterns that match more than one thing. I'm just turning X and Y strings into an enum. Enum is like you might know in C or C#, at least a simple kind of enum like this. It's just an alternative. And weird syntax like this, don't let that throw you for a loop. It's really just helping it with the type. If I said it like that, it'd be like, I don't know, how do you want me to parse that? In this case, it figured it out because it knew ultimately I wanted them to be, it wanted it to work with sizes, right? Because when we put it into a, where is it? What are we doing at that map? We're putting it into a fold up, right? How does this work again? Oh, we're putting it into this coordinate, right? It knows from this function fold up that the coordinate has to be a usize, right? So I didn't need to tell it what to parse it as, but I'm used to adding this. It's called a turbofish syntax. It's got a weird name. It's basically saying that since parse itself is generic, whenever I say generic, think of template. It's a function that has many different implementations based off of the type of the thing you're working with. In this case, the type of the thing we're working with is what do we want to parse it as? We want to parse it as an integer. We want to parse it as something else, not an integer, a floating point number maybe. We're parameterizing the function. As long as the compiler can find an implementation of parse that works with usize, then we're good. If I put something like string here, it's going to say like, I don't know how to parse it into that. The technical ways, it'll say the trait bound is not satisfied. If you work with Rust for long enough, you know what the lingo is, and so I know what a trait bound is, and it makes sense. At first, it's hard. I would say Rust has a pretty steep learning curve. I take it from no one chatting that you're either mystified or you've all left or I'm doing a really good job. I'm going to take it as a compliment. But anyway, I'm kind of jumping around in my code. I usually start with a unit test like this, which is based off of what the instructions give you as an example. So like, what are we on, date 13? If you go back to date 13, they start by saying, here's for this, when they say for example, I literally take that string and I copy and paste it into my unit test. And I look for what do they expect the answer to be if that's the answer, if that was the input. And they say it down here, 17. So I put 17, and I say, when I run my code on their example, I had better get what they say the answer would be, given that example, right? So in this case, we're representing a piece of paper and folding it once and counting the holes. So how we do that, we take our input string, we cut it into lines. For each line, we trim off the white space off of the ends of it. Then I'm constructing my paper object. My paper object is just a bunch of holes. The holes are represented as a hash set of coordinates. Hash set you can think of as like a mathematical set. So there'll be an memory allocated for every coordinate that is filled in with a hashtag. And they're fast to look up because we hash the coordinates to find the position quickly. So given that piece of paper, for every line in the lines, and I don't know why I did that. I probably didn't need to do that. I could probably remove that part. Oh, no, because I used it down there. Right, because we have the holes and then we have instructions afterwards, right? So for every line, if we find this line that's empty, we stop. That's this line between the holes and the instructions, right? We stop. Otherwise, we interpret it to be a whole location, right? Each one's a number with a comma in between. So I'm going to take that line, split it once at the first comma, and then map that X and Y to parse them as U sizes. And wherever you see it on unwrap, it basically means if it didn't work, crash. Panic, same thing, right? So we panic if the left side is not a number, the right side is not a number, or there was no comma at all in each of these three places where you see unwrap, right? But after we split it, insert just takes those X and Y coordinates and inserts into that hash map, right? So by the end of this, we've taken these coordinates and made something in memory that's roughly like this, but using a hash table. So after that, the rest of the lines are instructions that are formatted like that. So we take the lines. Oh, right. Part 1 says just do the first line. So we take that line and we just take the next line, make sure there is a line, strip the fold along prefix, split it the equal sign, map it into the left-hand side is the direction, the right-hand side is the coordinate. And then I take wherever the direction is up or left. We're going to either fold the paper up or fold it left. They're pretty similar. We take all the holes in the paper and we say, is it on one side of the fold or the other side? And if it's on the, for like folding up, if it's already up, we don't move it. If it's below, then we mirror its Y coordinate to fold it up and then collect it back into a set and we're done. And left is the same thing, only we're folding along a column. So if X is to the right of the column, we mirror it to the left. Otherwise, it stays where it is. Right? And then they just wanted me to just count the number of holes. So we just take the holes, take its length, convert it to a string, we're done. U64 is uint64t. That's right. Rust has a lot of abbreviated identifiers. So when you say like str, it's like string. Mute is like mutable. Fin is like function. U64 will be uint64, all that stuff. Yeah, you think of U size as like size T in C++. What is it in C#? I forget. I guess it would just be unsigned int or something like that in C#. I don't remember. Something that's guaranteed to work with addresses in memory. It's basically that what that type means. Silent but enjoying the stream. Yeah, at this point I'm just kind of explaining my solution, and I figure if people from Atom Stream are still here, they might not know what Rust is at all, this programming language, because Adam uses C# most of the time, or he's doing art, and I can't do art. But I can do C# and I kind of see where people would be coming from, and so this code, like, you can maybe get the gist of bits and pieces of it, but putting it all together, you'd probably get lost unless I tried to explain parts of it. So part 2 was basically do part 1, but fold all the instructions, and at the end just show what it looks like. So instead of where before we just took the first line, lines.next is the just take off the next line from the top, basically. We're iterating all of the lines, and so we're going to end up folding up or left more than once until we've exhausted all the input instructions, right? And then what this magic line does is says, turn paper into a string by using the display trait.
What I usually average.
And you just have to kind of know that. So if we look at my paper class, I have an implementation of the display trait here. The display trait says, given something, given ourself, and a formatter, send stuff to the formatter that you want to go into the string. So what I decided is first figure out the dimensions of our paper, and I'll turn off the inlay hints for a second to make it fit. So to figure out the dimensions, I say, take our holes, iterate through them, and do a fold of all of the coordinates together. So starting with 0, we put that into what's called an accumulator, which comes out here. This is a function object, so it's an anonymous function. It takes 2 arguments. It takes the current value of the accumulator and the next coordinate. And you're supposed to return the next value of the accumulator. So I say, take the accumulator and give me back the maximum between that accumulator and this argument. Hold on a second. Time to hydrate when I start coughing. So fold is kind of like the reduction of a set. This basically says, give me the maximum of all the x coordinates, right? And then this one is, give me the maximum of all the y coordinates. And then we're just looping from 0 up to and including the maximum y. And we're writing a line for each y coordinate. And we're writing it into the formatter. And we're writing specifically another string. And that string we form by going through all the x coordinates, iterating that, mapping each x coordinate to, hey, is there a hole at that position xy? If so, hash mark. Otherwise, dot. And then take that iteration and make a string out of it and print that string. So that's how you see the answer if I run this again. So after we did all the folding, this is what the paper looks like. And they said, well, read the paper and say what the characters are. Crazy that max x is a bound variable in the right side of its initialization. So the technical thing I should have done is just call this accumulator. And but what it's doing is the accumulator at the end becomes the maximum x coordinate, because every pass through this function, it's returning back for the next value of the accumulator. What is the maximum of these 2 values? It's like when you see something in Rust like acc max x. If you know something like C, the equivalent of that would be the maximum of x and accumulator. Actually, I guess it would be easier if I wrote it like this. Because in C, max is a global function. Like in C++, it would be standard max, right? But we'll just stick with C. I think it's in the math library. Just say the maximum of 2 values. In Rust, it's a little bit twisted. Max is a method on the integer type, and the other argument is just the only argument now. Also in Rust, you can omit lots of little things, like this is a function, right? But really, we could expand that to be return that, right? And really, that could be expanded to be a function that, some anonymous function, that takes accumulator, which is a size, and then an x and a y, which is a u size and a u size, and I'll explain what that is, and returns a u size. And the body of that function is to return that, right? So that's the full form of it. So this weird type is called a tuple. It's basically a combination of 2 numbers glued together, and you can get to the 2 numbers by binding each one to a name. And we put an underscore in front of names that we don't use. If I didn't do that, I would get a warning saying, ugh, you didn't use y. You should put an underscore to mark that you don't use it. Some people will just omit the y completely. I like to keep it there so I know it is the y coordinate. I'm just not using it. So, like, after a while, you just get used to the differences in the syntax. And then using blank space instead of the dot makes it more readable. Oh, yeah. So we can do that. If I just do that, now run the program, we'll be able to read it easier. Hashtag is also not a very good character. What would be a better one? Like a solid... Like, what's the ASCII code for a solid block? Or the Unicode character, right? I don't want Google. Unicode solid block. Is it this one? Full block? Yeah, this guy. Let's copy that. Can I just copy the text? It's not going to make this easy on me, is it? How about I just do that? And I can paste that here. There we go. Yes, Rust supports Unicode. It works just fine. In fact, we can actually print it like that. So much easier to read, don't you think? Anyway, that's what I'm going to be doing for the rest of December. So if you like what you saw, you're intrigued, fascinated, and I haven't driven you away again, we'll be doing this again. Not necessarily tomorrow, but probably Wednesday. I'll probably do 15 and 16 on Wednesday. So in the meantime, I gotta go. Let's raid somebody. Yeah, and in a little bit under 22 hours, you too can compete for the top 200 values, 200 times. Because really, it's a race. I always lose, because if we look at my personal stats, it took me an hour and 15 minutes to do both parts, 31 minutes. Guess how fast the top 100 people did? They did it in 4 minutes and 30 seconds for both parts. Just to get on the leaderboard, you had to do it in at most 14 minutes and 8 seconds. Part 1, they did it in under 2.5 minutes. The slowest person did it under 5 minutes. So they're ridiculously fast. If you go back to like the first Advent of Code where there wasn't a whole lot of competition, it was a little bit more reasonable. Like, as long as you did it within the first 3 hours, you could score. But now it's practically impossible to score because it's such a popular thing and the speed coders dominate. Yeah, it's a race to knowledge. Everyone gets their wins. The creator of Advent of Code says that as long as you learn something and you have, then I always like to add, or have fun, then you've accomplished something. Okay, so WhereIsX is doing day 14 in Crystal. I like the idea of that. I don't know what Crystal is. So let me make sure that they're still working on it. Okay, I got an ad, but hopefully WhereIsX is still going and we'll see some more Advent of Code. So everyone is doing Advent of Code in different languages. I did it in Rust. WhereIsX is doing day 14 in Crystal, and I've never heard of this language. Okay, I gotta wait another 10 seconds for this ad to finish. I want to avoid the problem of me raiding someone who's about to raid someone else. Okay, they're still going, so here we go. Starting the raid. Looks like I have not driven away everybody, so we'll see more of Advent of Code momentarily. I will pass the torch on to WhereIsX. I'll see you guys later. Have a good one. Bye.